Alright, what is up everybody? Here we are today trying out some pre-calculus practice tests to see if we're actually ready for calculus. First time, I guess, trying this out. I've already browsed through some of the questions of this, but some of them look quite hard. I don't really know. We're gonna see how we're gonna put up to solving it. Yeah, we're gonna try doing it together so that maybe you can learn, or I mean, if you don't really care about like learning pre-calculus or just math in general, it doesn't really matter. I hope you just get entertained at least on how I solve this stuff. Yeah, first time trying this type of video stuff out. Not really too sure, trying to get the gist of it. Hopefully you don't get too I guess does it seem too low quality to you guys? Yeah, we're gonna put out our board and we're gonna go straight to it. So here we are. So we're gonna try this first question. I want to simplify 10 to the power of n over 5 to the power of n plus 1. Okay, let's start off by writing the numbers here. N plus 1. Okay, now the first things first, in any math problem you have to identify what you have to use in order to solve it. Immediately at the top of my head is law of exponents. Why? Because you have exponents and you have to simplify, and the exponents usually have to have a variable as the top of the exponent instead of at the base. So basically it's the exponent. Your variable is the exponent. So step one's done, we identified it. Now what law of exponent do we use? Well, we have to find some correlation with 10 and 5. And the first thing you see here is correlation, so they're both divisible by 5. And is there any way to make 10 into its factors 5 and 2? There is. There is a law that basically makes it wherein as long as your exponent is the same and you get the product of the two terms, you can easily get the product of the bases and just copy the exponent, and that's correct. Okay, you can do that. Now what we're gonna do here is that we're gonna do the reverse. So 10 to the power of n is equal to 5 to the power of n times 2 to the power of n, and we just proved that. We proved that that's equal because 5 times 2 is 10, and that's a rule. Rule works. So 5n plus 1. Now what do we do next? Now we need to find a way to simplify this, right? So we need to find a way to make 5n to the power of n plus 1 into 5 to the power of n or 2 to the power of n. And I think it's a lot easier to do 5 to the power of n. I think it's the only way we can actually do it. How do we do that? So there's also another exponent law that we can use here, wherein 5 to the power of n multiplied by 5 to the power of 1 is equal to 5 to the power of n plus 1. Basically, when you multiply two things with the same base, you can add the exponents and just put them all together like this. So we're gonna do this, but in reverse again, right? So this is gonna become 5 to the power of n times 5 to the power of 1 all over 5 to the power of n. This is below 5 to the power of n times 2 to the power of n. So we're gonna how do you simplify this? We have two of the same terms, both are multiplications, so we don't have to care about weird fraction rules that you can't cancel out, and we can cancel this out. Okay, once we cancel this out, 5 over n times over 5 over n becomes 1. So yeah, hopefully you don't mind canceling. If you mind canceling, oh well, right? Too bad. We're trying to be as fast as possible. We're left with 2 over the power of n over 5, and this is your final answer. Let's see if it's in the options. There you go, it's B. Yeah. That's pretty fast. Well done. We take those. We indeed take those. Uh, Factor out completely 2y to the power of thing. Okay, I'm not saying this. This is actually really long. But what this is trying to tell us is to make it look better. Okay? That may not be what factor out completely means, but look, you can already see it doesn't look good, and the stuff down here looks a bit better because there's no negatives and stuff like that, right? Now, how do you solve this? Well, first things first, the cardinal rule when you see negative signs in the exponent is to put it below. Put that term below and remove the negative from the exponent, because that's what that negative means. A lot of people do not do this, I guess, immediately, because they're a bit scared that they don't know what negative means in the exponent. Some people don't actually know, so they skip these kind of questions, but that's what that means, right? So we're gonna try to do that. We're gonna have y. No. We're gonna make it a fraction movement, right? We're gonna put 2y squared. Okay, here, and we're not gonna make it negative because it's down in the denominator already. I told you that's what it means, right? And we're gonna have this as the numerator, the y plus 5 to the power of 1/2. Now the reason why I'm keeping its power of 1/2 and not doing anything to it, because fractions mean roots, so you can make the square root, is because, as you can see here, there's no square roots, and they use 1 to the power, you use it to the power of 1/2, so you don't need to make down the square roots. But yeah, I have an addition symbol here, y negative 1, so that's gonna be below. I'm gonna have it as y only, because negative, right? Y plus 5, oh, negative 1/2, so this also goes below, so we're gonna have y plus 5 1/2 all over 1. Yeah, okay, I got it. So next, oh, I actually did something wrong here. This 2 is actually in the numerator. Why? Because 2, the negative square root of the negative 2 exponent is only to the y, not to the 2. Yeah, sometimes people make mistakes, but as long as you're used to math, like making simple mistakes like that do not matter as long as you find it, like what I did, right? Don't need to care too much. What do we do here? Well, in order to make this look better than what it looks like right now, is to combine the two fractions together. How do you do that? You gotta get the same base and the same denominator. Because as long as they're the same denominator, you all know as fractions, it's a lot easier to put together. So how do you make y squared and y times blah blah blah, the same? Well, what I will do is multiply both sides of the right side by y. This will get us the y squared component of the left side. Basically, you gotta match these, right? It's a matching game. So y times y is y squared. We already got that matching. But what we don't have matching is y plus 5 to the power of 1/2. So in order to match that, we do the same thing on the left side, but multiply it into y plus 5 to the power of 1/2. Now you have to do it on both numerator and denominator to make it balance out. That's how I like to think of it, right? Because if you only do it to 1, then you're not balancing it, right? The weighting scale is not balanced. So we're gonna, if you simplify both bases, you're gonna realize that it's just gonna become y squared times y plus 5 to the power of 1/2. So because they're both the same, we're gonna put all of these under that, okay? Because that was the reason why we did it, right? That was the reasoning behind that. And then we're gonna do these. So y plus 5 to the power of 1/2 times itself. Remember, 1/2 is roots. So square root of something times square root of something is just something. Okay, so this is just y plus 5. So 2 times y plus 5. Let's look at the next. 1 times y is equal to y. Crazy, right? Just kidding. Okay. So simplify this. So we're gonna make this into 3y plus 10. How did we simplify that like that? Well, this is 2y plus 10 plus y, so 3y. All over, just copy this. Sorry that this looks like minus. It's really not easy to do this stuff digitally. But yeah. And yeah, after that, I don't think there's any other way to make this simpler. Let's look back. And indeed, there is no other way. It's a fraction, so it's not these two. So it has to be these two. And it looks exactly like this, right? Yeah. Yeah, we're right. Yep. Box this, final answer. Yeah, I think we got that correct. Probably. Nah, yeah, that's not probably. Yeah, we did get that correct. Sorry if that sounded like you shouldn't trust in that answer. Next, question 3. Determine the coordinates of the point common of the graphs 4x minus 3y equals 13 and 2x plus 4y equals negative 10. Now identify what this is. This is simultaneous linear equations. What does that mean? Basically a lesson where you learn how to find the same point in two different linear graph equations. In simple terms, it's basically this question. This is like the main problem of that lesson, and that's what it solves, right? What does it mean to find common point? It basically means there's an x value out there and a y value out there that satisfies both of these equations at the same time. Maybe that's why it's called simultaneous linear equations, because at the same time. Though honestly, I would just call the lesson common points, right? I mean, sometimes you don't use graphing. You don't make this a graphing problem or in a geometry problem. Sorry, terms are so weird in math sometimes, man. Just teach me how to do it, right? Sometimes. So how do we do this? So simultaneous linear equations. For me, the easiest way is to find a way to make one of the equations terms the same as the other term. What does that mean? So you can choose either x or y and then multiply both sides by a number to make the x or y the same as the x or y here. Basically the coefficient. So here we see 2x and 4y. So what do we multiply to 2x to get 4x? It's easily 2. So we can immediately go for that, right? Multiply both sides of this equation by 2 to match 2x to 4x. And I'm about to explain why you have to do this in the next step after we multiply both sides by 2. So this becomes 4x times 2. This becomes 4y. Apologies if the y does not look like a y for this one. And this becomes negative 20. So because we have the same coefficient, now we can subtract the equation off each other. What does that mean? So we're gonna, now in elementary school you learn how to do subtraction, and you make this like you set up you set up the operation with like a line below here, and you put this, and then you put the difference here, and then you put the subtraction sign here, and then you'll basically set up the whole formula in this really long way. Yeah, that's the same thing we're gonna do here. And then we're gonna subtract. We're gonna subtract these. So I don't like putting a subtraction sign here because you might mess up that this is negative 4x, which technically it is negative 4x because of the subtraction, but then you'll have to also give it to all of these, and it becomes a lot weirder in your head, at least for me. But yeah, subtract. So 4x minus 4x is 0, and this is the biggest reason why you have to make it the same, because when you make it the same and you subtract it, it just becomes 0, and then you're left with only one variable, and you can easily find what that variable is equal to, because you've isolated that one variable. This is basically, simultaneous linear equations is basically how do you isolate a variable when you have two. Yeah. So 8y minus negative 3y minus negative means positive, so this becomes 11y. Negative 20 minus negative 13 and minus 13 is just negative 33. Isolate y, so divide both sides by 11 to remove the multiplication of 11, and you get negative 3. Y is equal to negative 3. Last step is that you're going to need to plug this into either this equation or this equation. It doesn't matter which one, whichever seems simpler to you. For me, the right one, is simpler, so we're going to use that. For negative 3 equals negative 10. Simplify, this becomes 2x minus 12 equals 10. Am I correct? Am I correct? Yeah. Yeah, I think I'm correct. Hey. Oh no, this is why. Okay, this is also this negative. That's why I was like, wait, this doesn't look like any of these. I was like, why am I wrong? Okay. Next we got 2x. Add both sides by 12 to remove the negative 12. So negative 10 plus 12 is 2. X is equal to 1 because divide both sides by 2. And there you go. And lastly, make this into a point. If x coordinate is 1 and y coordinate is negative 3, then this is your final answer. Look at that. So perfect. 1, negative 3. Answer is B. Oh yeah, I think this video has already gone too long, so I think I'm gonna edit here. I said it's a 30 question test, so it's very, very long. But I hope you guys learned a bit. It's my first video, so I hope you guys enjoyed it. It's really cool, I guess, to teach online. And I don't know if you guys learned a lot. Hopefully you guys did. If you guys want more, just or if you want like certain topics I want to try out for me to teach using this type of teaching method, I hope you guys can just put down in the comments, I guess, what you want. And yeah, that's pretty much it. Thank you for watching.